So we made a short 3D introduction on the previous video about Fog of War done specifically on Age of Empires 3, and we gathered some ideas of how to do that inside Godot. Now it's time to actually implement them and make a Fog of War system based on the previous ideas. So let's go along and let's start it. So we have here a 3D world node, which is our world, it represents our world here. We have an environment, a sunlight. We have the map mesh for the terrain, which is using the terrain shader. I have the terrain shader mixer that I did on a previous tutorial. You can grab the code of the shader on godotshaders.com. I'm going to post a link in the description so you can also get it. So we're going to add a small bit of code to this to just use the Fog of War on top of it. So this shader is just the starting point of it. You can see the details of what is all about it on the previous tutorials. Then we also have a node 3D here that is just used to group the ball, just so we can have something to review the Fog of War as a reference to units. So later this could be units, so for now it's just a reference ball. And we have a little animation that I did here, basically just moves the ball. So let's see what this is all about. So I just animated various positions using the ball, and we are going to use that to track the revealing Fog of War. So this is all about the 3D things you are going to need to start this. Regarding the Fog of War texture, we have the Fog of War texture main control, which is just to group the units. We have here a fog tick timer. This basically is going to control how frequently does the Fog of War updates. So from my tests, it seems that the update time about 0.1 second was alright. Now this is something you can increase or decrease depending on the performance you want. Then we also have a sub-viewport container, which is basically going to hold the viewport itself. And this with code we are going to generate a size we want. So this is just for now at the minute. Then we have the camera 2D for the Fog of War texture. Nothing fancy about this one. Then we also have a Fog of War explored, which is a color rectangle control. So you're going to see how all of this gets together. But basically this is just the semi-explored areas of the Fog of War. Then we also have the Fog of War textures itself, which is using a sprite here. And importantly here about the sprite is we are using a material, a canvas item material, and we are multiplying it and unshading its light mode. Any parts we explore using the Fog of War is going to be white, so when we use multiply, it's going to actually dissolve the fog. So this is one of the ways you can do it. Then later we are going to save the sub-viewport as a texture for the terrain. So all of this is just a combination. Then finally you have here a Fog of War units node that is just going to keep track of units we want to add to dissolve the Fog of War texture. So this node is going to handle that. So this is everything you are going to need node-wise to start your project here. So let's go to our Fog of War texture. So let's start by giving a script to our Fog of War texture control. And I'm going to save here under my project, just this is fine. And here we're going to start. We want a signal for whenever you update the Fog of War texture, we're going to emit a signal so our terrain shader can copy the image from this Fog of War texture back to the terrain. Then next we are going to use our nodes there. Grab here our nodes. So we are going to be needing our camera. So this is all of the nodes we want. Okay, so now we have all of our nodes here. So we need an array to store locations we already dissolved the Fog of War. We also are going to need an image for the Fog of War main image, which we are going to use to dissolve it. And we also are going to need the texture, which we are going to use for the Fog of War. So you're going to see why we need these different variables here at different times. Next, we want to also store the Fog of War texture, but this time from the viewport. Basically, this Fog of War viewport texture is going to be used by the terrain shader. And we also want a map rectangle too. So we have some coordinates to work with. Now let's start with our function ready. We want our FOW sprite to not be centered. By default, sprites are centered. So we want to make sure our sprite texture is on the top there. So let's start by creating a new FOW. So let's go ahead and say that for this function we need a new map rectangle. And here we are going to set right ahead after we run the function our current map rectangle variable to be our new map rectangle 2. So now we want to set the viewport and camera sizes. So let's access our viewport and assign the size based on the rectangle we give it. So we are grabbing the size for our viewport. So something we also want to set it up just to make sure it is the same size. We're going to grab the FOW node, its parent, and we want to set its size also to the map rectangle size. So this is just to make sure that we don't have any weird scaling going on with the controls. We want to move the camera to be halfway the position of the size of the rectangle. So we want to center the camera. So you can do this by simply accessing the camera and saying that its position is going to be on point 0. So I want to start at 0 and add our map rectangle size divided by 2. So this is going to basically center the camera. Then next we are going to generate a full black image for our FOW. So this is going to be the basis of our FOW. So our FOW image is going to be equal to a new image, and we are going to create that new image. So a couple of things here. We want the map rectangle size to be an integer. Then next we want to set it to false, which is the argument for the using mipmaps. We don't want to use mipmaps. And we also want the image format to be a RGB. So this should cover our FOW main image creation. So now we have created the image we're going to use with the correct size. So now we need to fill it up black pixels. So we're going to access the image again, and we're going to fill it up. This is for RGB. Then for alpha, we want to put 1.0. Then next, we want to call a update for our FOW texture. So this is going to basically update the image we just created here to be assigned to the FOW texture sprites. So we're basically creating the texture to be the FOW. And let's do this inside another function. This is going to do two things. It's going to update the FOW main texture and the FOW sprites. So we are going to access our FOW main texture, and we are going to generate a new texture by using image texture dot create from image. And you can see here that it's going to ask for image, so that is why we have to separate. And I just noticed a bug here. It's get parents. We're going to create a FOW main texture from on image, which is our FOW main image. And finally, we just want to update our FOW sprites. And we're going to call this function update as soon as we create a new FOW. So as soon as you create a new FOW, we're going to update the texture here. So let's create our FOW dissolve function. So this function here is going to dissolve at a given position with a given image. The dissolve image we're going to use to dissolve the FOW is going to be a circular white sphere. So here we are going to basically grab the rectangle tool of the dissolve image. And we can do this by accessing our image and asking for its get used rectangle. And if you check this, this is going to return a rectangle integer, which includes the visible portions of the image. Then next, we want to offset the dissolve position by half of its size. It will be minus our dissolve image used rectangle dot size divided by 2. So this is going to basically offset to the center the dissolve image we given here. So now let's grab the map position. So our map position, now it's going to be equal our map rectangle dot position plus our dissolve position. And now we are going to actually dissolve that image. So how can you dissolve the FOW main image? Well, let's access first and do a blend rectangle. So this blend rectangle is basically the function you can use to mix two images together. It basically alpha blends. It's going to alpha blend a rectangle position from the source image to the image you give it at the coordinates distance. So it's going to clip accordingly to both image bounds, and this image and source image must have the same format. So if you don't follow the same format, you're going to see an area on the output window, and you can basically print the image format to make sure you are working with the same image format. So the blend rectangle first argument is the dissolve image we want. So we want to pass the image you are going to dissolve the fog of war. So in this case, it's dissolve image from the fog of war dissolve function on the top here. Then next, we want to grab the size from our dissolve image. So this is going to be our dissolve image, use rectangle. And finally, it's going to ask for a given position. And we already have this position at dissolve position. So now this should be basically dissolve your texture. Now we're going to simply ask for a update texture. So now that we have made the main functions for the fog of war dissolve, let's give it a quick test here. The only thing I'm going to do here is just to add the fog of war sprite we're going to use to dissolve it. So I just added here our fog of war dissolve sprite, which is this fella here. So what is important about this? This is an RGB8 texture. So basically this has to match the formats of the texture you're creating for the fog of war. So that is why this is important. Otherwise this is not going to work, because the blend rectangle function wants you to keep the same format for the image you are dissolving and the image you are using to dissolve with. I'm going to do here is just temporarily is just to save this as a resource so we can use here. So we want to give this dissolve sprite image a preload to be inside our script here. And I'm going to just go here and do a function input. So we are going to give a simple rundown test with this function here on our inputs. So we're going to say if the event we pass to the input is going to be a mouse button, and if that mouse button is equal to our mouse button left, and you can check the button index, and later if we actually press it, then basically we're going to, on the mouse position, we're going to basically dissolve using the dissolve sprite we just preloaded, which is this guy here. So this is just for a testing purpose here. So let's run our 2D scene locally. So we should basically see our Godot sprite, and once we click, we can use blend rectangle. Of course, we forgot to set it up the new fog of war here. So let's just give a new fog of war, and let's give a rectangle too. So now it should work. So we should see a black rectangle, and if we click, we should see the dissolve function in action. So as you can see, the dissolve function already works. And basically this is how we create the basis for the fog of war. You can see that it's somewhat like a unit is going to be explored. So this is basically the main idea of doing the fog of war. And this fog of war explored texture here, we can set on its layout to be on full rectangle. So it's going to occupy the entire full viewport container here, so it's parent container. So now if we run the scene and we dissolve at a given position, now you should see the famous semi-visible portions of the texture, which basically are going to be that thinner layer of the fog of war. As you can see, it works. So I'm going ahead and I'm going to basically disable this input function here that is just for testing. So now we are going to create a dictionary to hold the fog of war units and their corresponding data, so we can keep track of their position and to update the corresponding sprites inside our fog of war unit sprites. So let's go ahead and add a new variable here, which is going to be our fog of war. So we're going to have to keep a list of fog of war units we are going to do. So there are many different ways you can do this. This is the simplest way I am doing it. So now let's create a new function that's going to process that. So this is going to process all of our units. So this is the structure of the data we are going to be using. So the first one, we want to have the unit ID, an array inside of that, and we want the first argument of the array to be the node we are tracking, and we also want the sprite we are updating. So this is the simplest way you can keep a list, first of unique units, then we are going to assign copy their tracked position to the sprite node we want. So this is how we're going to be doing, and this is going to be for each unit. And this is going to represent our unit's data processing. So for each unit ID inside our FOW units data dot keys, so we first want to grab the unit ID itself, and unit ID is going to be an integer. So our unit data, which is going to be an array, is going to be equal our FOW units data using our unit ID. So with this, we should now have the unit data for our units data list. So now we can simply do the following. We can say we want the position to 2D. So this is going to be our tracked 3D position to 2D. So we can use from the 3D world inside the 2D to dissolve the FOW texture. This is going to be a vector 2. We want the unit data 0, which is our tracked node. If you notice here, this is the expected structure. So we want to grab our unit 0 as a node 3D, so I want to make sure it's a node 3D. Want its global position dot x, and as the second value of the vector we want the same thing, but it's z. So now we should have our coordinates to dissolve the sprite here. Then next we want to grab the sprite we are using. So the second argument for the unit data we are using here should be a sprite node. So we want to grab our unit data as a sprite. Our unit data at index 1 should be a sprite. We want to set its position to the position we just created from transfer the tracked position to D. So this is just to process our unit data. Now let's call a function, but now we need to call a FOW dissolve for every sprite we're going to have under the FOW units 2D. So let's do a FOW dissolve all FOW units. So basically the idea is this one's going to keep updating the position of the sprites. So we basically will be having sprites under our FOW units, and these sprites are going to hold the FOW, and we basically are just going to be using this sprite here to later dissolve the FOW. So just like we did with the left mouse click test. So how we are going to dissolve all our FOW units? So we're going to say for FOW sprites, which are going to be under the FOW units 3 node dot get children. So from their children, we're going to grab their texture. So the FOW sprite image is going to be from the FOW sprites, and it's just a sprite, not sprites. As a sprite 2D node, we want its texture and to get its image. So now we have the image to dissolve the FOW. So now we can simply just pass this to a FOW dissolve function. So the last thing we want here before we do that is to actually store that sprite position, so we don't dissolve a position we already have. Here vector3 is just to store 3 values, so this could be an array. So this is just to make things faster. What exactly we are doing here? We're creating a data structure that is going to hold the FOW coordinates, so x and y position, and the FOW size. So the idea is, once you have dissolved a piece of the FOW, we want to record that position and size to make sure we don't need to dissolve it later if a unit moves through there. So it's going to optimize performance here. So now we are going to actually call the dissolve for every sprite that we have on our 3 node there under our FOW units. So we are going to say, if we don't have that sprite stored position and size, inside of FOW stored. So this FOW stored is our array that's going to hold all the positions and sizes of each sprite's FOW, so we don't dissolve 2 places at the same time. So if we don't have that inside the array, then we're going to create a dissolve position So now we are basically dissolving using the FOW sprite image, which is from the sprites that is inside the FOW units 3 node get children. So we only want to have 2D sprites inside the FOW units there. And later we just need to store that dissolved position and size. So we're going to add a value here, and it's going to be the sprite stored position and size which we created here. So this is basically everything we're going to do to dissolve all FOW units that are inside the FOW units. And with this function, we are going to process all the FOW unit sprites to make sure they are tracking the current 3D nodes from the 3D world, so the positions. So in this case, we're going to use the ball 3D mesh here to be safe for FOW units data process. So now after we have done everything, we can finally update our timer to actually follow the FOW processing. So we are going to be creating a new function here. So this basically is going to update the entire FOW. We're going to do that by doing FOW units data process. So we're going to process all the units. Then later we are going to dissolve all the units. Then finally, we want to save the image from our FOW viewports. So our FOW viewports texture is going to be equal to a new image texture that we are going to create from an image, which is the FOW viewports. So we are actually using the viewport as a texture. And we want to grab its texture and its image finally. We just want to emit a signal that is going to warn our terrain mesh that the FOW has been updated. We're going to also remove this because we are basically going to use the world nodes to do it. And here the last thing we want is to grab our FOW tick timer to connect its timeout. So .timeout.connect, and we want to connect to the FOW tick loop. So now every time the timer restarts, we're going to be updating the FOW, and you can control the frequency just by changing this. And for a FOW to start, our timer to start. So with this, now the FOW should be updated every time. But now we don't have any FOW units, so we need to create those.